Hi, Science 7, topic 6 today on transferring energy, basically looking at 3 energy transfer methods: conduction, convection, and radiation. The first one, radiation, is the energy that moves in waves, not matter, and this energy can be reflected and absorbed, though. And the first kind that is mentioned here is electromagnetic radiation, like radio waves or X-rays, or microwaves, which can travel through many different types of materials. The second kind is infrared radiation, which is basically heat. So an infrared camera would pick up, they might use that off a helicopter and see where they can find a missing person or herds of animals, because you can detect the heat. All radiant energy can act as waves, be absorbed or reflected, and travel in straight lines across empty space at the speed of light. So, 3 ways that radiant energy can behave is that it can be reflected, it can be absorbed, or it can go right through something and be transmitted. So we look at the word thermal conduction, and that's where heat or thermal energy can move from one particle to another particle. So you can take someone's cold arm and put your hot hand on it and warm up their skin in that spot. So it's conduction is when you transfer that energy from one thing to another. So radiation was our first type. Conduction is our second type of energy transfer. So you can see that the heat is moving the very closest particles, but those particles will move the ones next to them, and eventually that will cause these to be bumped and moved and also go faster. So it's like warming something up where it's closest to the fire, further away from the fire, as those fast moving particles move the next ones over. So good conductors, you've heard of this before, would be things like metals that get hot really quickly, whereas insulators would slow down or stop the conduction. So something like fiberglass or styrofoam would be an insulator. Holding a styrofoam cup of hot chocolate is more comfortable than holding a glass cup or metal cup of hot chocolate, because that heat would go right into your hand. Third type is convection. This is only something that happens in liquids or gases, and it's how warm fluid moves. And basically it moves through a convection current. So energy will go from where it's hotter to where it rises and go to where it's cooler. So as you warm something, those molecules move and rise, and where they move from, that leaves an area that has less particles, and so the hot air will rise and the cold air will take its place and move into where those particles left space. That's basically the situation. And this could also happen in something like the hot water that's going to warm a swimming pool. You might have a hot water coming in here, and it will rise up and the cold water will take its place. So in this picture here, the warm air from the candle light is rising, and it will cool off as it gets up there, contract and fall, and take the place of that hot air that left the area around the candle. So 5 things in common of all of these. There's an energy source, like some chemical, nuclear, electrical, or mechanical source of the energy. There is a direction that the energy is spreading. There is a transformation because it's not always kept at the same kind of energy. Energy can be transferred from one type to another type. There'll always be some waste heat, and often there is some control system that will regulate it or give you information about the amount of energy there. So this volleyball example of the transfer says that your fist, picture A, has a lot of energy, and that energy is transferred to the volleyball when you spike it, and then you're going to feel that heat left in your hand because those from that slapping motion, some of the vibrations of energy are moving back to your hand and making your hand feel hot where you hit the ball. And then that ball hits the floor, and there'll be a slight temperature increase on the floor. But the transformation part is where you hear the bang of the ball hitting the floor, and you hear that sound. So it goes from movement to sound energy. And that energy is also transferred into the air as well around it. And in our last slide here, not all devices are efficient. A furnace might use the gas for 85% of that gas will go into the heat and to heat your home, and maybe 15% is lost. However, a regular kind of screw-in incandescent light bulb will, you guys are familiar with this, light bulb is probably only 5% efficient. So if you're getting it for light, 5% of the electricity going into it is actually going to be turned into light, but 95% of it is actually heat. So using that incandescent light bulb to heat up an area for your chicks to grow, or for a cat house or a dog house, would probably be a more efficient thing if you're using it for heat, because it's not a very efficient light bulb for light, which is why more people use like the new style, more halogen lighting or LED lighting, because there is a higher efficiency to those. Alrighty, that wraps up topic 6, my friends. Thanks for listening, and we'll talk to you soon.